You move a 1,200-ton sport across five continents in 38 weeks with zero room for delay. Welcome to System in Motion. I'm your host, Line Swallow. Formula One is a very technical, intricate sport, and what most people don't realize, there is the technicality is just the beginning. The logistics, it's a logistical nightmare. The reality is that it's not just 20 cars that are lining up on the grid, they're just moving. You have an entire mobile village that is actually being transported from race by race. We have 24 races. This calendar year, we have 24 calendar year races with 21 countries across 9 months, which includes three triple headers and multiple double headers. Triple headers meaning you have race after race after race, 3 consecutive weeks. Sometimes you're lucky where you have races in the same continent, just hopping the border across different nations. Sometimes you're hopping continents. Just this past weekend, just the last triple header was between Las Vegas, Qatar, and now we're in Abu Dhabi as the battle before the championship heats up between Lando Norris, Max Verstappen, and Oscar Piastri, the two teams of McLaren and Red Bull F1 team really are heating up, and the logistics is yet another battle that every team is battling against. We have three different ways of transporting huge amount of cargo across. You have air freight, road freight, and ocean freight are the main modes. When we talk about air freight, what actually gets transported are the cars, the engines, computers, telemetry, and of course the people themselves. The rule is if it makes the car go fast, it goes by plane because you have these updates of packages as well. Each package can, if it can improve 1/10 of a second for every lap, that's a huge margin gain. And across the race distance, we're talking about it accumulating to a couple of minutes. That's huge. Now, when we're talking from the second most popular uh, mode of transport, it's the road freight. Over here, it's usually done when you're talking from perspective of nations that are quite close to one another, usually in Europe. So if you have races in Monza, Austria, the Dutch Grand Prix, and others as well, usually the mode of favorable mode of transfer is road freight. Now, just a fun fact: some of these road freight are the convoy is actually over 5 kilometers long, consisting of over 400 trucks. This is huge, and hence it is truly a mobile village that is being transported, raced from one race to another. The hidden complexity that people usually kind of oversee is the fact that you have the local constraint, which is the fact that you have street races like Monaco, where you have very tight streets, and that just means that even in the race, that overtaking is very difficult. But from a logistics point of view, it is literally one truck in, one truck out. So you can imagine how difficult that is. And as we know, also in Las Vegas, you have the entire strip that is actually encapsulated by the race. So going around that is a huge nightmare by itself as well. Additionally, you have the international constraints as well, as you have various different uh, parts and folks traveling from one nation to another. You have to look at it from the point of view of ATA Carnet, meaning you need to have passport for certain parts and such as well, along with, of course, the folks themselves. Lastly, what we saw, the devastating crisis that we all kind of went through from COVID-19. Formula One did take 1 year off, but it was back up and again in 2021. And truly, that aspect of disruption was overcome by these teams in Formula One themselves. Ultimately, the goal of Formula One, especially from the point of view of sustainability, is that the goal is to have net zero by 2030, which is essentially 5 years from now. How can we do that when we are sending huge, incredible 1,000-ton cargo from race by race? How does that really happen? And that's where the technicalities and the technical innovation of Formula One really steps up by using, for example, alternative fuels, as well as now that we're in the hybrid electric motor and engine based. Uh, Now that we are in electrical and internal combustion engine based hybrid era, the fuel reduction, there's a huge amount of fuel reduction that is there. Now, again, coming back on the logistics side, let's look at some of the case studies. Some of the largest or the longest freight or cargo shipment that has occurred is actually from Austria to China, where you're essentially going thousands of miles. And after that, you have a triple header from China to Japan to Bahrain. Now, here it is in a single continent, but you're talking across the continent all the way from China to Bahrain themselves. Then, in between, you also have a European link between Imola in Italy, Monaco, and Barcelona. That is now that we're in Europe, that's usually taken up by uh, road transport. And then lastly, the something that we just experienced this past couple of weeks was between Las Vegas and Qatar, where on Saturday night you have a Las Vegas race, and the following Sunday you have a race in Qatar. So you have from one race to another race, you have 7 days. And of course, if you're considering free practice, qualifying, and such, in reality you have 4 days. So how do they actually manage this? Usually, what happens is there's a technique called leapfrogging, which is how you can basically have multiple cars, but you leapfrog one car to another so that you actually buy some time in between this transport. Not the most efficient way of doing it, but in certain cases, this is the only way to do it. Now, when we are looking from this aspect of logistics perspective, there are actually huge gains that can be had, especially because from logistics aspect, some of these solutions that are currently in place are the best that we have or the best that we can achieve right now. But when we're talking about this huge logistics problem, there is a place for further improvement. But where does the limitation really come from? The limitation is actually the computational side. We don't really have that high amount of computing for to handle this huge amount of problem, the huge amount of logistic problems that we encounter. So what do we end up doing? Simplify. We as engineers, we're best at trying to estimate in between the lines to get the basically management of the results with the simulation capabilities that we can have. But what if we didn't have those constraints? And that is what really this next generational computing can provide. By incorporating this hybrid nature of current day computing and future computing as well, the possibilities are endless. The fact that we can do this entire logistics aspect seamlessly and quickly, such that it actually has time to put into effect, can mean tremendous for an industry like Formula One. But this is a problem that is across the industry, horizontal to any industry that we can face, whether it be automotive, aerospace, energy, you name it. Now, to close off this podcast, I just want to kind of mention that this is not just about logistics. It is truly a systems engineering at planetary scales we're talking about. So next time you see the lights go out on Sunday, remember the most complex race of the week has already been finished. The race to get everything there. If the truck driver is late, next Verstappen doesn't race. Thank you.